You children nowadays, your electronic internet. It was her life support. Sorry? Yeah. Yeah, true that. Yeah, irony much. Okay, find the equation of the normal to the parabola. X squared equals 4y at the point, blah. So what do we have to do first? Yeah, find the gradient of the tangent first. How do we find the gradient of the tangent? We derive. And to derive, we need the equation in the form. Excellent. So what are we going to do first? Make it y equals. So we'll change this, and instead of it being x squared equals 4y, we'll go y equals x squared over 4. Yeah? And then we derive it, so y dash. Now I'm just using y dash because we've got a y there. I could use dx dy. Or I could use f of x and f dash x, but... Okay, so y dash equals what? 2x over 4? 2x over 4, which equals x over 2. Cool? I think it's important that you do that first step. You do that first step, just so you make sure that you are deriving it correctly. Now, I didn't put this as 1/4 times x squared this time and then make it 2 times 1/4, all that. So, all right, so we have the equation of the gradient of the tangent. Okay, so then what do? We're trying to find the equation of the normal this time. So what do we need to find an equation? What do we need? To find an equation of a line, what do we need? You could have 2 points. You could have what? Point gradient? Yeah. And we've got a point. Have we got the gradient yet? Nope. That's what we're finding out, isn't it? So, what do we want to do? We've got there, down here, we have the equation of the gradient of the tangent. What do you want to do? Well, we haven't got the gradient yet. We've only got the... Sorry? What do we got? We've got the equation of the gradient of the tangent. We're not looking for the tangent. Well, we could find the gradient of the tangent at that point first. Is that what you mean? So to do that, we would what? Yeah, okay, well, let's do that. So we're going to go, okay, so at minus 8, 16, M1 equals, well, I'll call it MT. So you know it's the tangent, the gradient of the tangent. Cool? So MT equals minus 8 over 2, which equals minus 4. So the gradient of the tangent at that point is minus 4. Now, what do we know about the gradient of a normal? Excellent. M1 times M2 is minus 1. Now, let's go back to calling that M1 then. I was trying to be clever. I should never try and be clever. It doesn't suit me. So, what's M2? Close. I just rearranged that. So I've got M2 equals minus 1 over M1. Negative reciprocal. So it's minus 1 over minus 4, which is the same as 1 over 4. So the gradient of the normal at that point is 1/4. Happy with that? Cool. Now what? I think we should now. What are we going to use? What's the point gradient formula? don't forget it is on your formula sheet, point gradient. So we've got y minus y1 equals m outside of x minus x1. So we've got y minus 16 equals a quarter outside of x minus or plus 8. Cool. Y minus 16 equals x over 4 plus 2. Y equals x over 4 can't add up, plus 18. Okay. Now we could leave it like that, but they probably won't want us to leave it like that. Let's get rid of the fraction, yeah? So I end up with 4y equals x plus 72. Which we could also write as x plus 72. Oh, get rid of that, sorry. X minus 4y plus 72 equals 0. AX plus BY plus C equals 0. So general form of a linear equation. Is that all right? So realistically, in that question, what are the things we had to do? We had to derive it to find the gradient of the tangent. Then we subbed in the point, so we found the gradient of the tangent at that point. Then we rearranged that to find the gradient of the normal at that point. Then we used that gradient and the point and put it into our point gradient formula to find the equation of the normal at that point. Happy? Awesome.